Hello. Today, we're going on a journey through the story of an invention that changed the rhythm of humanity. The wheel turned, water boiled, and the heartbeat of civilization began to race. Steam engines, not merely a technical innovation, but the power source that triggered one of the most profound transformations in human history. The driving motor of the Industrial Revolution. The force that set the rhythm of cities, turned the gears of factories, and shaped the roads that tied the world together. On this journey, we will step by step explore a story that runs from the first experimental attempts to James Watt's groundbreaking invention. From factories to railways, from steamships to modern industry. The hot breath of steam did not only move machines, it changed the direction of civilization itself. The power of steam, discovering steam as an energy source. At the heart of the Industrial Revolution lay not only iron and steel, but also an invisible yet driving force, steam. However, the systematic use of steam as an energy source was not an accidental discovery. It became possible only through decades of effort by minds who observed the laws of nature and sought to understand physical principles. Steam is born when heated water expands and produces pressure. Yet, for centuries, this basic principle existed merely as the sound of water boiling in a kettle. Only when people realized that behind that sound lay a revolutionary potential did everything begin to change. Production, transportation, and the social order itself. By the late 17th century, European mines were being dug ever deeper, and flooding was severely disrupting output. Traditional methods of draining water had become insufficient. This practical problem raised a question that would open a new chapter in engineering history. Could pressurized steam be used to perform work in a continuous, reliable way? The earliest experiments with steam showed that energy could be converted into a controllable, directed form. This was not just a technical step forward. It marked the moment when human beings ceased to be passive observers of nature and began to intervene in it, using an understanding of its forces. From that point on, steam became not only the driving power of machines, but the motor force of the modern world. The first sparks, Savery, Newcomen, and early steam experiments. The entry of steam power onto the stage of history rests on the shoulders of engineers who built the hinges of the door that opened onto modernity. One of the first to crack that door open was the English engineer Thomas Savery. In 1698, when he patented his device under the title "A New Invention for Raising Water by Fire." His aim was to pump water out of flooded mines. His design used steam pressure directly, which meant high temperatures and a serious risk of explosion. For that reason, its use was limited, but it still entered history as the first practical water pump powered by steam. Roughly 20 years later, Thomas Newcomen followed in Savery's footsteps and developed a safer and more effective system. The machine he built in 1712 is considered the first engine to use atmospheric pressure to drive a piston. It was primarily used to pump water from coal mines and became the standard technology for decades. However, it was inefficient, consumed large amounts of fuel, and produced only linear, up and down motion, which limited its range of applications. The Newcomen engine was a turning point. It proved that it was now possible to convert energy into mechanical work. Yet one crucial piece was still missing: circular motion. Steam power had to be transformed into not just a pump, but a true engine, a source of rotary motion that could drive complex machinery. That leap would come with James Watt's revolutionary contributions. Savery and Newcomen showed that steam technology was not just an advance in engineering, but a conceptual revolution. Humanity was no longer content to watch nature. It was learning to direct it. Watt's revolution: rotary motion and efficiency. By the mid-18th century, steam technology was still in its infancy. The Newcomen engine did the job, but it was clumsy, wasteful with fuel, and generated only vertical movement. At just this moment, a name stepped onto the scene: James Watt. In 1763, while repairing a Newcomen engine, the Scottish engineer noticed how much energy it wasted and conceived an idea that would change the course of history. Watt's greatest invention was to carry out the condensation process in a separate chamber. This meant the cylinder no longer had to be cooled down and reheated with every stroke, dramatically reducing energy loss. This seemingly simple, but in truth revolutionary modification doubled the efficiency of steam power. Steam could now do far more than pump water. It offered potential as a major driving force. But Watt did not stop there. The true turning point came when he developed mechanical linkages that allowed steam engines to produce rotary motion. In 1781, with his crankshaft and connecting rod system, the steam engine was transformed into a machine capable of continuous rotation. That made it suitable for factories, textile mills, grain mills, and eventually vehicles. With Watt's engines, steam power evolved from a novelty that imitated nature's rhythm into the beating heart of industrial production. It was no longer just an energy source. It became the motor that carried civilization forward. That is why the modern unit watt is not only a measure of power, but also a monument to a remarkable leap in human history. Steam and the factory. The birth of mass production. Once steam power could be converted into rotary motion, the industrial landscape changed irreversibly. Production was no longer dependent on human or animal muscle. Water-powered mills by rivers faded into history. Machines could now be installed almost anywhere, especially in growing urban centers. This transformation heralded the birth of the modern factory. In Britain, this process sparked a revolution in the textile industry. When Watt's engines were linked to looms and spinning machines, production capacity surged, goods became cheaper, and reliance on manual labor declined. Tasks that had once taken hours of handwork could now be completed by machines in minutes. Handmade began its transformation into a nostalgic, almost romantic notion. But this revolution altered not only production, it also reshaped the culture of work. In the factory system, time was measured by the rhythm of machines. Shifts stretching from early morning to nightfall laid the foundations of the modern working day. Human labor no longer followed the rhythms of nature, but the pounding of pistons and the hiss of steam, as steam-driven machines were centralized in factories. Industrial buildings rose in cities. This, in turn, accelerated migration from rural areas to urban centers, fueling the rapid growth of modern cities. The Industrial Revolution was no longer just a matter of technology. It became a profound social transformation. The birth of railways. The evolution of steam transport. One of the most striking reflections of the Industrial Revolution was the emergence of steam railways, which transformed land transportation from the ground up. Steam engines revolutionized not only production lines, but also the way goods and people moved. One of the earliest and most famous steam locomotives was George Stephenson's rocket. In the Rainhill trials of 1829, it outperformed its competitors and became a symbol of a new era. Railway lines first spread through the English countryside, then across Europe and the Americas like veins through a living body. Journeys that once took days could now be made in hours. Factories could move their products to markets more quickly and more reliably than ever before. Railways made it easier to supply raw materials and connected inland regions to the outside world. Coal and iron from mines were carried directly to industrial centers. Cities arose at railway junctions. Small towns grew into major urban centers. Steam's rapid dance along the rails did more than change transportation. It redrew the entire economic map. Yet railways were not simply economic tools. They also provided social momentum. People began traveling to places they had never seen, finding new jobs, and encountering new cultures. The distant became near. The slow became fast. The trains pulled by steam engines accelerated the tempo of human history. Steamships and the acceleration of global trade. The story of steam that began on the iron rails of the Industrial Revolution soon spread to seas and oceans. Steamships that brought the age of sail to a close did more than speed up global transport. They rewrote geographies, trade balances, and colonial systems. One of the early and remarkable examples, the SS Great Western, crossed the Atlantic between England and America in just 15 days in 1838, a revolutionary time compared to contemporary sailing ships. No longer did ships have to wait for favorable winds. Downtime was minimized. Sea travel became more predictable and more regular. With steam-powered vessels, the movement of goods accelerated, and the very concepts of time and distance were redefined. Raw materials essential to global trade, cotton, coal, tea, rubber, and more, reached wider markets via steam transport. Ports became busier, and coastal cities grew into major centers of global commerce. Steamships also strengthened the hand of colonial empires. Steam-powered navies allowed imperial states to project power over distant territories far more easily. Steam carried not only trade, but political power. These ships also opened the way for mass migration. From Europe to America, from Asia to Australia, people set out to build new lives. Steamships became the carriers of modern migration movements. Through this lens, we see how steam was transformed into the infrastructure of globalization. The force that revolutionized land transport also reshaped the seas, laying the foundations of a truly global economy. Social impacts: time, work, and urbanization. The steam engines at the heart of the Industrial Revolution did more than speed up production processes. They transformed humanity's perception of time, the structure of work, and the nature of urban life. Before industrialization, production depended largely on agriculture and handicrafts. People lived according to the rhythms of nature. Seasons, daylight, and weather determined when they worked. With the arrival of steam-powered machinery, time began to be defined by machines. Workers now labored in factories according to rigid shifts. Start times, breaks, and finishing times were fixed by the clock. This gave rise to the concept of industrial time. The clock became a necessity. In an age that sanctified punctuality and productivity, time quite literally became money. Human labor came under tighter control. This new mode of production triggered a massive migration from rural areas to cities. People flocked to urban centers in search of factory jobs, and cities grew in haphazard fashion. In many European cities, slum-like housing proliferated rapidly. Infrastructure lagged behind, and public health problems became widespread. At the same time, however, this transformation laid the foundation for modern urban life. Public transport, municipal services, workers' unions, and social rights all took shape in this period. The rhythm of steam did not change only physical spaces. It also altered social relations. Family structures, class divisions, and the inclusion of women and children in the workforce all took on new forms. This new order strengthened the capitalist model of production and played a crucial role in the construction of modern society. In short, with the hiss of steam, not only machines, but the fabric of society, the perception of time, and the structure of cities were radically reshaped. It was one of the deepest transformations in human history, both physically and mentally. The science of steam, thermodynamics, pressure, and mechanics. Steam engines were not just technological inventions. They were key turning points where natural laws met engineering. To understand the power of steam, we must first grasp the science behind it. Thermodynamics. This discipline studies the relationships between heat, energy, and work. And most of the key concepts that made the Industrial Revolution possible were forged here. At the center of it all lies the heating of water. When water is heated and transformed into steam, its volume increases dramatically. This expansion creates a high-pressure environment. That pressure can then be harnessed to produce motion. This physical process lies at the heart of every steam engine. Early engineers struggled to understand how best to channel this power, while figures like James Watt developed systems to control and transform it. Watt's separate condenser turned steam back into liquid water in a controlled way, significantly boosting efficiency. Heat energy could thus be converted into mechanical work with far less waste. This process also laid the groundwork for the birth of mechanical engineering. Cylinders, pistons, valve systems, and crankshafts transformed the driving force of steam into rotary motion, bringing machines to life. Steam power was now capable not just of up and down movement, but continuous rotation, a development that had revolutionary effects, especially in transportation and manufacturing. From a scientific perspective, steam engines played a central role in the understanding of the second law of thermodynamics, the concept of entropy. The fact that energy tends to disperse into more disordered forms provided the foundation for efficiency calculations in engineering. In short, steam was not merely a physical phenomenon. It was a cornerstone of modern engineering, of energy science, and of scientific thinking itself. Machines driven by steam accelerated not only production, but the development of science. After steam, internal combustion engines, and the age of electricity. Although steam engines ignited the Industrial Revolution, their reign did not last forever. By the late 19th century, technological needs and an increasingly rapid pace of life demanded energy sources that were more compact, more efficient, and more portable. In this context, internal combustion engines emerged not just as technical inventions, but as heralds of a transformation that would change the pulse of an entire era. Internal combustion engines operate on the principle that fuel, such as gasoline or diesel, burns directly inside the engine's cylinders. Because the energy conversion takes place inside the motor rather than in an external boiler, these engines are much lighter, faster, and more economical. Nicholas Otto's four-stroke engine, introduced in 1876, was one of the revolutionary steps in this field. Shortly thereafter, pioneers like Carl Benz and Gottlieb Daimler integrated such engines into vehicles, opening the door to personal transportation. The birth of the automobile not only altered the face of cities, but also created an entirely new industrial sector. Yet the search for energy did not stop there. By the mid-20th century, electric motors emerged as powerful alternatives, especially in trains, subways, and industrial machines. Electric motors drew attention for being quiet, cleaner at the point of use, and mechanically simpler. However, the limited state of battery technology at the time delayed their widespread adoption in cars until the early 21st century. Today, internal combustion engines still dominate globally, but electric vehicles are quietly conducting a revolution. Led by brands like Tesla, battery capacities are increasing, charging infrastructure is improving, and global awareness of carbon emissions is growing. This transition is not just technological. It has economic, political, and environmental dimensions as well. The evolution of one form of energy into another is more than a technical development. It represents a redefinition of humanity's relationship with nature, of the structure of cities, and of production and consumption chains. Beyond steam, This dance of energy eras continues to determine the speed and direction of civilization. Steam carried into the future, the legacy of an engineering age. Today, steam engines may look like relics from a bygone age, but, in reality, they still live on deep within modern technology. The principles of steam pressure, piston systems, energy conversion efficiency, and heat-work relationships are actively used in everything from nuclear power plants to geothermal facilities. Even in heat pump technology and advanced thermodynamic cycles, the basic ideas behind steam are being reinterpreted and carried forward. Steam engines, in other words, left us not only turning gears, but a lasting way of thinking. An alternative past, a civilization without steam. But what if steam had never been harnessed? This would not merely have been a technical gap. It might have caused a major delay in humanity's sense of time and progress. Without steam, animal-powered transport might have dominated for much longer, and industrialization might well have slipped into the 20th century. Steam energy, as a key factor that accelerated civilization, changed not only machines, but also the pace at which we think and the way we produce. In a world where the wheel had been turning for thousands of years, steam was the moment it first became a true driving force. Steam reborn. A sustainability perspective. Today, as we struggle to meet our energy needs, we are revisiting the steam systems of the past through the lens of environmental responsibility. The carbon emissions caused by traditional steam engines are giving way to more sustainable systems in modern technology. For example, generating electricity with steam from solar-heated water both honors the principle of steam and offers environmentally friendly solutions. In this way, the machines of the past are being reborn through the green engineering of the future. Steam is no longer just a voice from history. It is also an inspiration for what is to come. Today, we have seen the legacy of steam through three different windows. On one side, the engineering principles transmitted from past to future. Enduring knowledge that still lives in power plants and scientific experiments. On another, an alternative scenario that invites us to imagine how much slower humanity's journey might have been had steam never been discovered. And finally, steam reinterpreted in the age of sustainability, as the inspiration for an energy vision in harmony with the sun, the wind, and nature. Steam engines may now sit in museums as piles of iron, but in truth, they are symbols of the human mind's determination to understand and transform nature. The motors of the past continue to guide today's science and to shape tomorrow's technologies. Thus, the sound of steam is not merely a noise echoing in history. It remains an invisible melody that carries the rhythm of civilization into the present and the future.